Now, before we start space, how to demarcate? How to demarcate? That means what? Space begins with what? There should be a particular demarcation line that should demarcate. This is the particular line after which what? A space should begin. So that particular separating line, that particular imaginary line that demarcates a space is called what? Karman line. Okay. So space suppose consider it. This is the earth surface. This is what? Earth surface. At around 100 kilometer from the surface of the earth, at around 100 kilometer from the surface of the earth, there exists an imaginary line. Is what? An imaginary line. Imaginary line. This particular imaginary line is called what? Karman line. Okay. What? It's a Karman line. This line is not arbitrarily selected. Obviously, it is being selected after proper research is being carried out. It has been accepted by Aeronautics Federation also. Now, why we have selected this after 100 kilometers? There should be a particular reason for it. So let us discuss some of the reason. For example, first reason is what? If we talk about atmosphere, okay. So obviously in the atmosphere we have atmospheric molecules are there, and those atmospheric molecules, they are responsible for what? Genesis of air drag forces or air resistance forces, and these air resistance forces, what? They are going to generate frictional forces. For example, suppose consider it, this is your air molecules, these are your air molecules, and these air molecules, they are responsible for what? Producing air resistance forces. Always remember this, air resistance forces jo hai, it will develop opposite to the direction of motion. Suppose the satellite, if you consider a particular spacecraft, if it moves in this particular direction, then obviously when you talk about air resistance force, this particular air resistance force, it will be developed in this particular direction. This is for your air resistance forces. That means what? When you talk about air resistance forces, obviously it is responsible for reducing the speed of the vehicle, because it is acting on the opposite side. First point. Second point, apart from reducing the speed of the vehicle, it will be responsible for what? Genesis of friction. It will be responsible for what? Producing frictional forces. And you are quite aware of it that when you talk about the frictional forces, it will generate heat. And because of this heat, what will happen? The spacecraft is a strong possibility that it will get damaged. Okay. Second is what? When you talk about climatological phenomena, is it? They are restricted to troposphere and stratosphere, upper layer of the stratosphere, and upper layer of the stratosphere. Generally, when you talk about the climatological phenomena, if you go through the geography, they are restricted to tropospheric region, but subtropical westerly jet streams hota hai, that is responsible for carrying some of the hygroscopic particulate matter into the stratospheric region. And due to that particular reason, if you talk about like cumulonimbus clouds, they are what? Extended up to stratospheric region. So if you talk about like climatological phenomena, for example, climatological phenomena, it will also get affected. For example, formation of cloud, it requires what? Hygroscopic particle. For example, just now, for the purpose of controlling the Delhi pollution, what? They have carried out cloud seeding experiment. They have a what? Sprayed silver iodide, but rain was not being developed, precipitation was not being developed. What is the reason? Because hygroscopic particles, it was not present. Hygroscopic particles are basically responsible for what? They are attracting the ice molecules. The ice molecule, they will get attracted, they will get accumulated, and finally what? They will start dropping onto the earth with acceleration due to gravity. That will be under free fall condition. So cloud clear, what is required? Hygroscopic particle is required. We have to carry out the proper, we have to see whether these hygroscopic particles are present or not. If they are present, then only we can go for what? Carrying out cloud seeding experiment. And because of that, effectiveness of cloud seeding experiment is only 2%. Much, it's only 2%. Okay, so obviously if the spacecraft are being parked at this particular zone, they will be responsible for what? Disturbing climatological phenomena. What this it will disturb climatological phenomena. Third thing is what? Obviously when you talk about the satellites they are being basically designed for observation of celestial things. No doubt when you talk about the satellites, one of the important factor is what? They have been designed to carry out earth related activities also. For example, we are getting telecommunication services. It's because of satellite. Disaster management prone areas, they are being continuously monitored with the help of what? Satellites. Resources monitoring are being done with the help of satellites. These are the applications of satellite. But apart from that, when you talk about the satellite, the essential purpose is what? Look for the celestial things. So if the satellites are parked over in this, third is what? Observation of space. Observation of space. So when you talk about the observation of space, it can be better done when the satellites are being parked beyond atmospheric region. Beyond atmospheric region, because वहां पे क्या होगा? We do not have the particulate matter, we do not have the atmospheric molecules, and because of that, we can clearly see those celestial things. So third is what? If the satellites are being parked below Karman line, observation of space, it will get affected. And considering all this factor, what? International Aeronautics Federation, they have given this particular Karman line that exists above 100 km from the surface of the earth. When you talk about the observation of a space, suppose we have satellite that is being parked below this particular limit. Okay, so do you think observation of space can be done? No. It has to what? We have different atmospheric particles, we have different particulate matter, different things are there, and because of that, what will happen? We'll not get the proper image. Blood image formation will take place. But if it is being parked above 100 km, what will happen? Clear sky, and because of that, the clear images are being formed. And considering all this fact, International Aeronautics Federation, they have selected this particular line that is called your Karman line. Is it okay, Akash? Okay. Now see, UPSC is notorious for what? Making a simple statement into a difficult one. The question can be like, Karman line separates aeronautics from astronautics. You getting my point? The statement, it will be like Karman line, it separates aeronautics from astronautics. It separates aeronautics from astronautics. Things have become difficult. They are the two critical words, aeronautics and astronautics. First point. Now what is this? What is aeronautics? It deals with what? Aeroplanes. Astronautics, it deals with space related activities. Okay, so when you talk about aeronautics, it means what? You are talking about what? Aeroplanes and all. We are talking about aeroplanes. And when astronautics means what? Space. Now this is the simplified form. If you consider, suppose this particular region is called what? Outer space. Outer space. As per Outer Space Treaty, this particular outer space do not fall under the sovereignty claim of any country. It belongs to all. Outer space belongs to all. No country can claim this particular region belongs to me. What? It do not fall under the sovereignty claim of any country. Any country. Okay, that means what? The area beyond Karman line, it is not being controlled by any country. It belongs to what? Outer space. That means what? Either it belongs to no one or it belongs to everyone. But if you consider suppose this particular region, okay, so suppose this is India, so obviously this particular region, it will be under the sovereignty claim of India. So this is all about your Karman line. Is it okay? Now we have used the word aeronautics and astronautics. So let us define this. Okay, for everyone. Now, aeronautics. That means what? They are applicable towards aeroplane. Please do let me know how aeroplane operates. What is the basic principle? What is the basic principle through which this aeroplane will operate? ATC, what's that? That is being used for what? To manage the aeroplane, to track whether it is moving into the predefined path or not, to exactly see whether it will land at the requisite port or not. You know? So when you talk about aeroplanes, on which principle it works? Yes, it works using what? Bernoulli's principle. It works using what? Bernoulli's principle is basically responsible for providing the aerodynamic uplift. Are you getting my point? So in aerodynamics, Bernoulli's principle is responsible for providing aerodynamic uplift. Okay, and because of this aerodynamic uplift, the aeroplane world, it will uplift. Now, what is Bernoulli's principle? See, if you go through this Bernoulli's principle, it's not there in NCERT. For getting Bernoulli's principle, you have to read class 11th NCERT. In a way, it's a very different language, but UPSC is not interested to know the definition. Rather, it is what? Interested to know its application part. In a very simple language, it says that increase in velocity leads to what? Decrease in pressure. If there is an increase in velocity, decrease in pressure, and subsequently decrease in pressure means what? Increase in pressure. Now we have discussed about the aerodynamic uplift. You have seen the aerodynamic wings. These aerodynamic wings, they have been designed so that what? They can sustain Bernoulli's principles. Look over it. Consider aeroplane, and this is what? This is your what? Aerodynamic wings. This is your what? Okay. Wings. What have wings? When you talk about the wings, it operates using what? Bernoulli's principle. How? Just I have discussed that it means what? When you talk about the significance or relevance part of it, says that increase in velocity will lead to what? Decrease in pressure. Decrease in pressure. And on the other hand, if there is what? Decrease in velocity, it will produce what? Increase in pressure. Increase in pressure. Velocity increases, what will happen? Pressure will decrease. If velocity increases, pressure will what? Decrease. On the other hand, if velocity will decrease, pressure will what? Increase. Now this aerodynamic wings, they have been designed in such a fashion that velocity increases over here. What will happen? Velocity increases on the top, and because of that, pressure what? it reduces. At the bottom, what will happen? Velocity reduces, and because of that, pressure increases. So here you can see that here what we have, here we have high pressure beneath the aerodynamic wings, and on the top what we have? Low pressure. The movement of molecule, it will always be from high pressure to low pressure. The movement of molecule, it will be like this, and this movement of molecules, it provides what? Aerodynamic uplift. Provides aerodynamic uplift, and that is why what I have discussed, when I talk about the Karman line, it is responsible for demarcating aeronautics with that of the astronautics. Because when I talk about the aeronautics, one of the important factors is what? Aerodynamic uplift, and this aerodynamic uplift required what? Difference in the pressure, and difference in the pressure, when it will come? When we are in the atmospheric region. Is it? Okay? And see, if you talk about like Odisha, it is being regarded as disaster capital of India. Okay, or if you go to northeast region basically, or during the time of a storm, if you go to the village, you can see that when you talk about the cow shed, Gausala ki baat karte, we talk about the cow shed, they are being covered with what? Teen. When you talk about the cow shed, suppose this is a particular cow shed region. This is what? Cow shed region. Cow shed. Here what you can see, it is being covered with teen. Okay. During the time of a storm, what will happen? These teens, they will what? Uplifted, and they will be thrown away. They will be thrown away in some other locations. What is the principle? The same principle. Bernoulli's principle. See, this type of question, it can be asked in the UPSC. For example, if you talk about like Odisha, here the coastal belt regions, they do not go for what? Manufacturing these rooftops and all those things. Rather, they use what? Such type of a structure. And such type of a structure, they are more vulnerable towards what? More damage. Because of this particular structure, they will be under continuous Bernoulli's principle, and because of that, this teen, they will get uplifted. The teen, when you talk about this particular teen, they get uplifted because of what? Bernoulli's principle. Okay. Write it down. Now, these are the different layers of atmosphere: troposphere, stratosphere, mesosphere, ionosphere, and exosphere. These are what? Different layers of atmosphere. But when you talk about the Karman line, it lies at 100 km from the Earth's surface. That means what? It lies in between mesosphere and thermosphere. Okay, so draw this diagram and mention this. Do it fastly. Throw this and just mention that when you talk about the Karman land, it exists between mesosphere and thermosphere region. Rest of the things you can read on your. Okay. Now, no need to prepare the notes. I will say the first space race. Okay, it was started with what? Hot air balloon. For the first time, we thought of what? Carrying out the vertical profiling of atmosphere. Basically, we wanted to see how does the density of the atmosphere it decreases when we what move upward, and from there itself we started what? Space exploration. The first experiment that was being carried out, it was being done by hot air balloon Explorer-1, but it failed. And what we have went for the second attempt, that is what? Explorer-2, and with this what we have carried out the vertical profiling of atmosphere up to 26 kilometers. Next is what? A space exploration timeline. For the first time, what we have started with 1957 USSR, and the first satellite that was been launched, Sputnik 1. It carried what? A dog. What is the name of the dog? Laika. And this particular dog died because of overheating. We'll see how it happens. This particular dog died because of overheating. Okay. Now, objectives of Indian space program. Now we'll start with what? Launching station. So the first launching station, it was developed at Tumba Equatorial Rocket Launching Station. It is at Tamil Nadu. Basically, it was not a complete equipped space station. Basically, it was a church, and for the purpose of launching the rockets, for the purpose of launching the satellite, we have just converted into what? Tumba Launching Station. Now, why this particular location is being selected? Just because Tumba was selected because it was very close to the magnetic equator of the Earth, making it an ideal location for the scientists to conduct low altitude upper atmospheric and ionospheric studies. We have discussed about the magnetism of the Earth, and there we have discussed that when you talk about the Earth at the poles, we have maximum magnetic intensity, and because of that maximum magnetic intensity, what we have? Northern lightnings in the form of aurora borealis, aurora australis. There in yesterday classes we have discussed, and that particular region is what? More prone towards the cosmic radiation. But when you talk about the equator side, there we have what? Lowest magnetic intensity. Because of that lowest magnetic intensity, the cosmic radiation impinging on the Earth's surface, they will be reflected back. Obviously, what the sky seems to be clear. So earlier it was being thought that this could be the best particular location, and there we have started with what? Tumba Rocket Launching Station. While the Nike Apache India first rocket was an American rocket, just 4 years later, India launched its first indigenous sounding rocket. So this is the India sounding rocket. We are carrying it. What is the name? The indigenous rocket, Rohini 75. This is how we used to carry the rocket during that time particular. Okay. Now we are going to study with what? We are going to study the different theories. Okay. The first propounded theory is what? Geocentric theory. And this particular model, it was being propounded by Aristotle. He stated that geocentric, Earth is at the center, and all other planets, including Sun, they will revolve around the Earth. Geocentric, Earth-centric. Earth is at the center, and apart from that, all other planets, including Sun, they will start revolving around the Earth itself. Next, during the 16th century, this particular theory, it was being changed to what? Heliocentric theory. Helio means what? Sun. Now the Sun is at the center, and all other planets, including Earth, they will be what? Revolving around the Sun in a circular orbit. In a what? Circular orbit. But presently, the space, launching of satellites, selection of orbits, inclination of orbits, how the gravitational forces, they will get converted into a particular orbital velocity. All these things we study under what? Kepler's law. Kepler's law. So right in the first statement, earlier when you talk about heliocentric theory, it says that Sun is at the center, and all other planets, including what? Earth, it revolves around the Sun, but is a circular orbit. That was being challenged. Kepler says that no, it's not a circular orbit, rather it's what? Elliptical orbit. So when you talk about the elliptical orbit, we do not have the center. Rather what we have? Two focus. sun will be at one of the focus, and earth, it will be revolving around the sun in elliptical orbit. So write down this statement. I have to explain the second, in the first statement. Right. What is the second law? A planet sweeps out equal areas in equal interval of time. Kepler's second law. What is there to discuss? भी खाली है. Kepler's second law. Kepler second law. Planet sweeps out equal areas in equal interval of time. The planet sweeps out equal area in equal interval of time. In equal interval of time. This is the particular statement. Let us see. The concerned orbit is what? It is elliptical orbit. It's the what? Elliptical orbit. Elliptical orbit. Let us consider a scenario. That consider it. These are the two focus, F1, and this is what? F2. At this particular point, F1, suppose we have what? Earth. This is what? Earth. The Earth. And consider a satellite. So this is a satellite. It started from a point A1. This satellite started from a point A1. It moves to what? A2. A2. Okay, the satellite, it started from point A1. It moves to A2. Okay, and it has taken what? Time T1. This is the area. This is the area that is being covered. Is it? Let us consider this area as A1. A1. Okay. Clear? The satellite has moved from point A1 to A2, and this is the area that is being covered, A1. After that, the satellite will come at this particular point, A3 point, it moved to A4 point, and this is the area that is being covered. Let us consider this area as A2 and time is what? T2. Okay. So now this is the scenario. This is an elliptical orbit as we have discussed in the Kepler first law. At this point focus, this is Earth and these are the satellites. This is one particular satellite. Now the satellite, it has moved from point A1 to A2. What is the area covered? A1. Area covered A1 with respect to time T1. This is the area. This is what? This is the area. Okay. Now again it has moved to point A3. Move to point A4. What is the area that is being covered? A2 within what time T2. Now if you look at this particular zone, do you think this particular A1 area is equals to A2 area? Yes. Okay. What is the statement? If a planet sweeps out equal area and equal interval of time, that means what? If we consider time T1 equals to T2, then obviously what will happen? Area A1 equals to A2. Is it okay? It's written over there. A planet sweeps out equal area in equal interval of time. That means what? If I say either this time T1 equals to T2, or let us consider for the sake of simplicity, if area A1 equals to A2, then time T1 equals to T2. What does it mean? What does it mean? So now let us see, consider for the sake of simplicity, consider this time as 1 hour. Time equals to what? 1 hour. So obviously this 1 hour here also what? 1 hour. Now if we replace this, if you convert this curved space into the circumference, what will happen? This particular, if it is being converted into a straight line, so suppose it will be like this. If this curvature, if it's been converted into a straight line, that means what? Within 1 hour, the satellite, it has covered this particular distance. And in the same over here, within 1 hour, it has covered this distance. Is it? No. The planet sweeps out equal area and equal interval of time. If you go through the simplified method, what we can see? We can see that within 1 hour, this much distance has been covered by the satellite. And on the other hand, that much distance. So this particular position is called what? Closest position. Here it is what? Closest position. So from this, do you think it is evident that when a satellite is closest to the Earth, its orbital speed will be higher? Is it? Within 1 hour, it has covered this distance. That means what? And within 1 hour, it has covered that distance. It reflects that if a satellite is closest to the Earth, orbital velocity, it will be higher in comparison to the faraway positions. Is it? So from here, if we talk about this application part, says that if a satellite is closest to the Earth, if a satellite is closest to the Earth, its orbital velocity will be much more higher in comparison to its far away position. Is it? Within 1 hour, it has covered 100-kilometer distance. Okay. And within 1 hour, it has covered 20 kilometers. So what does it mean? Here the speed, it will be like 20 kilometer per hour, and here it will be like 100 kilometer per hour. Same thing I have written. If a satellite is closest to the Earth, its orbital velocity will be much more higher in comparison to its far away position. Closest position 100 kilometer per hour, and far away position 20 kilometer per hour. Write it down. Okay. Write down the third law. The square of the orbital period of a planet is proportional to the q of the orbital semi-major axis. What is orbital period? Please, what is orbital time period? Orbital time period means what? The time taken by the satellite to complete one revolution on an elliptical path. How much time a particular satellite it will take to complete one revolution around its elliptical orbit. That's what its orbital time period. Obviously, the orbital time period depends upon the orbit itself. When you talk about the orbit, it is dependent upon the major axis itself. So that means what it says, that the orbital time period, it depends upon its major axis. Okay, so write it down, this particular statement. Yeah. क्लास में सब बच्चा लेकिन ऑपोजिट सिक्योरिटी दिखाया. Okay, so what we have learned from the Kepler law, it says that if a satellite is closest to the Earth, what orbital velocity is much more higher in comparison to its what far away position. Why so? What is the reason? So let us see. Now we have discussed that there are two particular positions. One is what? One is your perigee position. That means what? Perigee position means what? The nearest position, and apogee position means what? Farthest position. So when perigee position, consider it. For example, Earth and the Moon. Okay. Obviously, what Moon is, if you consider Earth and the Moon, suppose if Moon is at perigee position, that means what? Closest position, what will happen? High tides are caused. As per the Newton's law of gravitation, we know that each and everything in the universe with a mass will always what? Affect each and other thing in the universe that is having the mass too with what? Gravitational forces. That means what? If we consider Earth and the Moon, there exist gravitational forces. Obviously, it's because of Earth's gravitational effect on the Moon. Moon is having what? Moon is moving in its particular orbit. But definitely Moon will also cause some of the gravitational effect. What effect? It can be seen in the terms of tides, oceanic tides that are being caused. Now we are having two particular locations. One is what? Perigee. Perigee is the closest position. So in the closest position, what we'll have? Maximum gravitational effect. That means what? The Moon will exert its maximum gravitational effect when it is at perigee position, and because of that, the tides that are being caused, it will be much more higher. And on the other hand, apogee position, when the Moon is situated at a very far away distance, what will happen? Low gravitational force. and because of the low gravitational forces, the tides that are being caused, it will be what? It will be lowest tide. Lowest tide means what? It's the tide's amplitude, the height, it will be what? In the lowest range. Now the question, why the satellite revolves rather than staying still in space? Suppose there are two conditions. If you park the satellite into the space, if you park the satellite into the orbit, okay, as under free fall condition, it should what? It should be falling on the earth. It is not happening. First point, why so? Even if you have parked it into the space itself, it should stay stagnant at that particular point, but instead of staying stagnant, it start revolving around the particular orbit. Why so? Why it is? That means what? The satellite is not even under the free fall condition. That means what? First thing. The second thing is what? It is also not staying stagnant. Rather what? If it is in part, it will start revolving around the earth. Why so? What is the factor responsible for it? When a satellite is being parked into the space, so what will start revolving in the selected elliptical orbit. Why so? Q. Gravity. Everywhere gravity is applicable, but in different sense. How direction will? Obviously, Earth को revolve करेगा. Why so? Huh? करवाएंगे. What? My simple question is, suppose if I am throwing this object into the space, what will happen? It will attain a certain height as per my applied force. After that, what? It will be under free fall condition. That means what? It will be falling on the Earth's gravity with what? G. Same thing, same condition, it should be applicable on the satellite also. That means what? If I have thrown the satellite, first is what? Either it should be attracted toward the Earth, it should start falling on the Earth. It is not happening. Second, it should remain stagnant at rest. It is not happening. Rather, it what? Revolves around the Earth. What is the reason? Yeah. Let us see. First of all, we'll talk about the escape velocity. It is the velocity through which if anything is thrown, it will remain into the space itself. Okay, it won't fall back into the ground. That's called escape velocity. It is same for each and everything. If I have to throw this pin, I have to throw with escape velocity. If I have to throw the elephant, it has to be thrown with what? Escape velocity itself. And the velocity is constant, 11.2 km per second. Okay. So this satellite, it has to be what? Parked with escape velocity. But once it is being parked, it will start revolving around the selected orbit. Why so? We'll see. This is what? Earth. Karman line. Okay. Suppose this is the selected orbit, and this particular orbit we have selected, it's around 1,000 km from the Earth's surface. This is the particular satellite that is being parked. This is what? Satellite. This is being parked. Okay. Just after parking the satellite, it will start orbiting in this particular orbit. Why so? See, basically what happens? Here the two forces are acting. The first force is what? Two forces are acting. When you talk about the first force, it's what? Earth gravity. It's what? Earth gravity. Earth gravity, it is continuously acting on the satellite. Okay. It's the Earth gravity. What? Earth gravity. It's what? Earth gravity. It is acting from all the side. That is the Earth gravity. First force is what? The first force is what? First is what? Earth's gravity. Earth's gravity force. It will try to pull the satellite. It will try pull the satellite. It will try to pull the satellite. If okay, and because of this, it is acting at the center. When you talk about the Earth's gravitational forces, it is continuously acting on the satellite, and it is trying to pull the satellite towards its center. That becomes what? It's a centripetal forces. It is acting as a what? Centripetal forces. It is acting as a centripetal force. Centripetal force. Okay. On the other hand, when we have parked this satellite into the space, just after parking, this satellite will gain the orbital velocity that is equivalent to its Earth's gravity. That means what? This orbital velocity, this satellite is moving with what? Orbital velocity. Is it? Second is what? The orbital velocity of the satellite, it generates a force, that is the centrifugal force. Orbital velocity of the satellite. Orbital velocity of the satellite generates centrifugal force. Okay. Now, when the satellite is being parked into the orbit, just after parking into the orbit, you leave it, it will start revolving around the orbit with some orbital velocity. This orbital velocity, it is generating a force, that is what? Centrifugal force. At any point in the orbit, the Earth gravity is being balanced by its orbital velocity. At any point in the orbit, Earth gravitational forces acting on the satellite is being balanced by the orbital velocity of the satellite, because orbital velocity is what? It's generating centrifugal forces. That means what? Is centripetal force of the Earth. It is being what? Balanced by the orbital velocity of the satellite. Orbital velocity generates centrifugal forces, and because of this, the satellite what? It will stay in this particular orbit, but it will not stay, because continuously what? Earth gravity is acting everywhere, and because of this, the satellite. So at any point, if you consider at any point in the orbit, Earth gravitational force, Earth gravitational force is being balanced. Earth's gravitational force is being balanced by the orbital velocity of the satellite. At any point in the orbit, if you talk about any sort of point, suppose if you consider this particular point also, the Earth gravity force is being balanced by the what? ऑर्बिटल वेलोसिटी ऑफ द सैटेलाइट, ऑर्बिटल वेलोसिटी ऑफ द सैटेलाइट, ठीक है ना। किसी भी पॉइंट की अगर हम बात करेंगे वहां पे क्या होगा, कंटिन्यूसली द ग्रेविटेशनल फोर्सेस दे आर बीइंग बैलेंस्ड बाय द orbital velocity of the satellite. Since this gravitational force is acting everywhere, what will happen? Satellite, it has to move. Done. Now, just can you correlate when you Kepler second law? Kepler second shows that if satellite is closest to the Earth, it will have maximum speed because if it is closest, it will be experiencing higher gravitational forces, and to counterbalance these higher gravitational forces, it will have what? Higher orbital velocity. Consider this scenario. So this is the Earth. Okay, we have 3 orbits. This is the satellite. Satellite is moving with VA. Satellite is moving with VB, and this satellite is moving with VC. So here in this particular scenario, what will happen? VA is greater than VB is greater than what? Okay. Escape velocity. Escape velocity is what? That is the velocity through which, if anything is thrown, it will be what? It will totally escape Earth's gravity. So write it down. So now suppose if I have to throw this pen into the space, the other end I have to throw elephant. Do you think the escape velocity it will be same for both the things? Why so? Because when you talk about the escape velocity, it is what? Depends upon 2g m upon r. 2g is gravitational constant of m is the mass of the earth and r is the radius of the earth. Escape velocity. So let us calculate escape velocity. It is what? It will be same for every object. It will be same for every object. That means what? Escape velocity, what? Constant. It is what? Constant. What is the value? It's your 11.2 kilometer per second. Earth mass is what? M. Radius of the earth is what? R. Consider this a particular body. Okay, this is a particular body. Okay, that is at a small height h. It has to be thrown with what? Escape velocity. It has to be thrown with escape velocity. Consider it. Now, if you go through this Newton's law of gravitation, if by what? Newton's law of gravitation, force of gravity is what? G, gravitational constant, mass of earth, mass of body upon radius of the earth. Is it? The force of gravity, as per the Newton's second law, force equals to what? Mass into acceleration. Now, if we talk about this particular body that is at a particular height, r square. Okay. R square. Clear? Is it? Now, if we talk about this small body of mass m, it is at height at obviously what? It will be attracted toward the earth, and that thing can be calculated as what? Mg. So here to like m mass of body into g mass of earth, mass of the body, r square. We have calculated g equals to what? Gm upon r square. Is it? Now to calculate velocity, we have a Newton's law. V square equals to what? U square plus 2g, as initial velocity is 0, 2 g equals to what? Gm upon r square. The distance, consider it, radius of the earth. It will be like 2 gm upon r. So escape velocity is what? Square root of 2 gm upon r. है ना? Square root of 2 gm upon r. 2 is constant, g is what? Gravitational constant, m is mass of the earth, r is radius of the earth. That means what? If you want to calculate the escape velocity, escape velocity is independent upon the mass of the object to be thrown. It is not depending upon this particular mass. Obviously, it will be constant for everything. G is what? This particular g, gravitational constant. It is constant throughout the universe. Mass of the earth is also constant. Radius of the earth is more or less also constant. And because of this, escape velocity is constant. It is independent upon the mass of the object to be thrown. It is independent upon the mass of the object to be thrown. Of the object to be thrown. Then, so see, suppose this is a particular body of mass m, it has to be thrown. Okay, this is earth, mass m, r is the radius. force of gravity is what? I have discussed the Newton's law of gravitation. Force of gravity G mm, mass of the earth, mass of the body upon r square. Now this force from Newton's second law, force equals to what? Mass into acceleration. We are talking about this particular body, it is attracted toward the earth. So that particular acceleration will become acceleration due to gravity. So mg equals to what? Okay, so this particular mass will get cancelled, and g we will have gm upon r square. This is the acceleration due to gravity. I have calculated in the class also when we are discussing what the acceleration due to gravity. G equals to what? Gm upon r square. This we have calculated, acceleration due to gravity. Now we have Newton's laws of motions. Through this Newton's law of motion, there are certain equations. Final velocity square equals to initial velocity plus 2gs. Initial velocity is 0. Final velocity, what we want? Escape velocity. Escape velocity square equals to what? 2. We have replaced the value, substituted the value. This particular gs, s is the distance. S is the distance. We in this particular case, we have considered let the distance be radius of the earth. Okay, this square cancel, and with this what we received? Escape velocity equals to what? Square root of 2m. So this particular escape velocity, it is what? Independent on this mass. It is not depending on this mass, and because of that escape velocity, it will be same for each and every object. Okay, na? Yes, force will vary. Suppose if I have to throw this pen into the space, I have to throw with what? Escape velocity. If I have to throw the elephant also, I have to throw with escape velocity. But in this particular case, less force is required. And there what? More force is required. And because of that, here less fuel consumption will take place. And there what? More fuel consumption will take place. But they have to move with escape velocity. What will happen to you into the space? I have parked you at around 400 kilometers from the Earth's surface. What will happen to you? Huh? Suppose oxygen cylinder है, then what will happen? अगर ऑक्सीजन से हाँ इतना तेज से घूमेंगे ना विदिन 2 मिनट्स अपना हाथ कहीं और घूमेगा, सर कहीं और घूमेगा. नहीं गलत है. मेरे हिंदी जो सीरियल्स वगैरह महाभारत रामायण में दिखा रहे कि स्पेस में जाके लड़ रहे हैं. हाँ? कैसे लड़ रहे हैं? लॉजिक है? चलिए, okay. Now type, we are going to discuss the types of orbit. So basically we have two different types of orbit. One is the circular orbit and other is what? elliptical orbit, and according to the altitude, on the basis of the height, we have what? Low Earth orbit, middle Earth orbit, and high Earth orbit. Okay. Orbits, two types: circular orbit, elliptical orbit. On the basis of altitude, three types: low Earth orbit, middle Earth orbit, and high Earth orbit. And so the first is what? Low Earth orbit. Low Earth orbit. Low Earth orbit. When you talk about the low Earth orbit, what is the range? It starts from 200 kilometer up to what? 2000 kilometer. Okay. Start from 200 kilometer to 2000. Is it okay? Consider it. This is the Earth. This is your what? Low Earth orbit. The range of a low Earth orbit, 200 to 2000 kilometers. Now, different features associated with the low Earth orbit. Features. First is what? Since at low Earth orbit, what will happen? Earth gravitational forces is very high, and because of that, orbital velocity will be also high. What first is what? Due to high gravitational forces, in low Earth orbit, due to high gravitational forces of Earth acting on the satellite, satellite's orbital velocity, will be very high. Is it? Okay. Since at this particular point the Earth gravitational forces are high, because of that, to compensate, to counteract the same, satellite will move with what? Higher orbital velocity. First point. Since higher orbital velocity, what does it mean? Lower orbital time period. Low orbital time period. What is time period? We have discussed the time taken by the satellite to complete one revolution around the orbit. So obviously, what if it is moving with very higher orbital velocity? That means what? Its orbital time period, it will be very much low. Generally, it is being considered that if a satellite is being parked into the low Earth orbit, The orbital time period, it will in the range of 90 minutes, 90 to 100 minutes. So orbital time period, because of this. Second is what? Orbital time period. Orbital time period will be around 90 minutes. And since orbital time period is 90 minutes, what does it mean? It means that it can carry out multiple revolutions within 24 hours. Is it? Because if it takes around 1.5 hours to complete one revolution, within 24 hours it will carry out 16 revolution. So that means what? Within 24 hours, satellite can carry out 16 revolutions. So these are the different features of low Earth orbit: higher orbital velocity, low orbital time periods, and because of that, multiple revolutions around the Earth. Okay. So presently, if you talk about the low Earth orbit, we have parked International Space Station is being parked at low Earth orbit, particularly at 400 kilometers from the Earth surface, for the purpose of carrying out research on microgravity. Is it? Why so? Because if something is being damaged in the International Space Station, astronauts can move over there and they can go for the rectification of the same. Hubble Space Telescope, it is also being parked at 560 kilometers from the Earth's surface. The first serviceable telescope that is being parked into the space. If something happens to what? Hubble Space Telescope, it can be what? Rectified. Right on this point. Right on these 2 points. Yes. No, little bit it will vary, little bit. It's in between 85 to 100, 85 to 105 minutes, something like that. On an average, we consider 90 minutes. What I have discussed, it's a natural process. If you park certain satellite into the orbit itself, that particular satellite, it will gain the velocity itself, because at this particular point there will be certain gravitational forces. In accordance with the gravitational forces, it will gain the orbital velocity. If the gravitational forces are high, automatically it will gain high orbital velocity. If the orbital velocity is low, for example, I have quoted the example, if I parked around 400 kilometers, you think you have certain engines, but you will start revolving. What is the reason? It's a natural process. In the space, naturally, for example, moon, it's a natural satellite. Do you think it's have certain engine? No, naturally. Because of Earth gravity, because of Earth gravity, that is what continuously acting on the moon. But moon have a fixed orbit to move. Why? Because the Earth gravitational forces that is continuously acting on the moon is compensating the same with the help of what? Orbital velocity, and that is why the moon is revolving around the we'll discuss when we talk about the Gaviat orbit. We'll discuss this. Okay. Second orbit is what? Polar orbit. Polar orbit. Polar orbit. Polar orbit. So polar orbit is what? It's a type of low Earth orbit. It's a type of low Earth orbit. That means what? What are the features we have discussed with the low Earth orbit? That means what? Higher orbital velocity, and because of that, low orbital time period, multiple evolution, all the things, it will be applicable to polar orbit itself. So polar orbit is what? A kind of a type of it's a type of low Earth orbit, orbit around the poles, orbit around the poles. Okay, that means what? This is the Earth, this poles, North Pole and South Pole. So orbit around the poles. The orbit around the poles is called what? Polar orbit. Since it is a low Earth orbit, what we have discussed here, high orbital velocity, high orbital velocity, and because of this, what will happen? 90 minutes is the orbital time period, and multiple revolution around the multiple revolution around the Earth. Multiple revolution around the Earth. Okay. Now there are ranges of polar orbit. That means what? Suppose this is the equator. This is what? Equator. 0 degree, and this is what? North Pole 90 degree. So if you talk about the range is like this is 60 degree. So 60 to 90 degree from the equator, range of polar orbit, range of polar orbit. From poles it will be like 90 degree to 60 degree, but if you consider from equator, it will be your 60 to 90 degree. Okay, मैं जिससे क्वेश्चन पूछूंगा वही मुझे बताएंगे. कुछ स्टूडेंट्स प्रीवियस भी हैं हमारे यहाँ. Clear? Akash, do let me know. We have discussed about the polar orbit. Okay, if the satellite is being parked into polar orbit, obviously what? It will have higher orbital velocity, so that what? It can carry out multiple evolutions within 24 hours. Do you think if the polar satellites are parked into polar orbit, they can cover the entire surface of the Earth? If the satellites are parked into polar orbit, they can cover the entire surface of the Earth. How? So they will, suppose this is the Earth, they will be moving North Pole to South Pole. What I'm asking? Entire surface. You think it will cover the entire surface of the Earth? Huh? Why? So what? It will carry out the multiple revolution. That is why I'm asking. Do you think it will cover the entire surface of the Earth? Yeah. This is, please, this is Earth. This is how the satellite that is parked in the polar orbit moves. But apart from that, you have to consider that Earth is not a stagnant body. It also rotates from west to east. This is being covered. 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 So within what? 16 revolution, It will cover the entire surface of the, ठीक है? So polar satellites will cover the entire surface of the earth, will cover the entire surface of the earth, since earth rotates from west to east. हाँ, मैंने कहा ही वहां लिखा, इट्स ए काइंड ऑफ लोअर ऑर्बिट, हायर ऑर्बिटल वेलोसिटी, 90 minutes time period, multiple revolution. So what? The type of it's a type of low earth orbit, na? It's a type of low earth orbit. What I have said, when you talk about the low earth orbit, the orbit height, it should be from 200 to 2000. It can be from your equatorial side also, it can be from your pole side also. ठीक है? Done? And since polar satellites, they are being part closest to the earth, obviously what? This is being used for the purpose of what? Monitoring the resources. Since closest to the surface of the earth, obviously क्या होगा? Photographs जो लेंगे, it will be what? In the HD, high resolution based photographs it can take, and because of that, it can be used for the purpose of what? Resource monitoring. So applications, when I talk about the applications, polar satellites, Earth observation satellite. When you talk about the Earth observation satellite, for example, if I have to particularly monitor a particular zone itself, particular area itself, I will be using what? Polar satellite, because it is closest to Earth resources. Earth observation satellites, Earth observation satellites, west to east. Earth resource monitoring satellite, Earth resources monitoring satellite, तो हमें satellite image, what the satellite images, what we are getting, satellite images, okay, we are getting it from the polar satellite images. You are quite aware of Google Earth. In the Google Earth, what you can see? Satellite images, you know, the Earth surface itself. We are getting it with the help of polar satellite. Now, geosynchronous orbit. Write down this. Geosynchronous orbit. geosynchronous orbit. Geosynchronous geosynchronous means what? Synchronous means what? Sync means what? To match. To match. So that means what the name itself indicates that geosynchronous orbit. That means what? If the satellite is being parked at this particular orbit, satellite orbital velocity, it will be matching with the rotational speed of the Earth. Okay, so this is Earth. Okay. Using Kepler's law, using what? Kepler's third law. Kepler's third law. It is being calculated that there exists an orbit at around 36,000 kilometers from the surface of the Earth. At around 36,000 kilometers from the surface of the Earth. This particular orbit is called what? Geosynchronous orbit. Okay. If that means what? If the satellite, if what? If the satellite parked over here, what will happen? Satellite rotational speed, it will be matching with the speed of the rotational speed of the Earth. See, suppose this is the Earth. Suppose consider this region as complete Earth itself, and this is the Delhi. I have parked the satellite over what? This particular region, Delhi itself. What I have discussed, geosynchronous at 36,000 kilometers from the surface of the Earth, an orbit is there. In that orbit, what happens? Satellite orbital speed, it will be what? Equivalent to the Earth rotational speed. That means what? It will be continuously over what? Delhi itself. Okay, na? Why so? Because we have discussed that the orbital velocity of the satellite, it depends upon the gravitational forces of the Earth. At that particular point, using Kepler third law, it was being calculated that because Earth is having certain rotational speed, Earth is having certain rotational speed. For example, at equator, the Earth rotational speed is equivalent to 1670 km per hour. 1670 km per hour. We know it. So we have used Kepler third law, and slowly at geosynchronous orbit, that means what? At 36,000 km from the surface of the Earth, it has been found that the Earth rotational speed or the satellite orbital velocity, it's equivalent to what? Earth rotational speed. If the satellite is being parked over the Delhi, it will be continuously monitoring Delhi itself. So now here what will happen? Satellite orbital velocity equals to the Earth rotational speed. Okay. And because of this, the satellite will have infinite dwell time. That means what? That particular satellite parked, it will be continuously monitoring a particular region itself. Infinite dwell time. आप लोगों ने notes में यहाँ updated it. See, by positioning a satellite so that it has infinite dwell time over one spot on the Earth, we can constantly monitor the weather in one location, provide reliable telecommunication services. Have what? Infinite dwell time over one region. Infinite dwell time over one region. And considering this fact, when you talk about the applications, the different applications of geosynchronous orbit is what? They are being used for the purpose of what? Navigations. When you talk about the navigation satellite, GPS and all those things, those satellites, they are being parked in geosynchronous orbit. Example, navigation. Navigational satellites, they are being parked over here. Example, GPS, America, India's IRNS. Okay, other is what? Telecommunication services. Satellite's orbital velocity equals to the Earth's rotational speed. UPSC may confuse you by quoting what? Revolutionary speed. Not revolution. It's what? Rotation. Now, the other is what? Geostationary orbit. Geostationary orbit. It's a special kind of geosynchronous orbit. What? It's a special kind of geosynchronous orbit. Clear? Geostationary orbit. It's a special kind of geosynchronous orbit. Dwell time means what? Okay, see. When you talk about polar satellite, what we have discussed, suppose this is India. We have parked polar satellite so that what we can continuously monitor a particular region. But we have seen that when you talk about the polar satellite, since it is being parked closest to the Earth, it will have higher orbital velocity so that it crosses Delhi within 1 hour. That means what? That particular the dwelling time of that particular satellite over Delhi is what? Only 1 hour. 9 to 10 a.m. in the morning. After that, it will be covering the other regions. But when you talk about the geostationary or geosynchronous satellite, they have been parked at 6,000 kilometers from the surface of the Earth, and because of that, they have the same speed as equivalent to the Earth rotational speed. So that what? It will be continuously monitoring this region. Infinite. Now, geostationary orbit is what? It's a special kind of geosynchronous orbit. What is that? See, this is Earth. Okay, this is the equator. Okay, so geostationary orbit, it's a special kind of geosynchronous orbit. What does it mean? See, it's what? It's a circular geosynchronous orbit. It's a what? Circular geosynchronous orbit. Circular geosynchronous is what? It will have 36,000 kilometers. Okay, na? It's a circular geosynchronous orbit around the equator, having inclination with the equatorial plane at 0 degree. That means what? Suppose this is the Earth. Is it okay? This is the equator. So the orbit, this is the equator. Suppose this is 36,000 kilometers. The orbit is like this. Okay? Exactly circular orbit, 36,000 kilometers of the equator with no inclination. Exactly 0 degree. If it becomes like that, that means what? It is inclined. अगर थोड़ा सी वक्त ऐसे हो जाएगा तो that means what? It is inclined. So write it down. That is the definition. It's a circular geosynchronous orbit. Circular geosynchronous orbit. Circular geosynchronous orbit having inclination